picture this, an asteroid the size of Mount Everest slams into the Earth, wiping out the dinosaurs and plunging the planet into darkness.
It sounds like science fiction.
Right.
Yeah.
But it actually happened 66 million years ago, and it set the stage for a wild ride of recovery and dramatic climate swings, and ultimately the rise of humans.
That's right.
Welcome to Cosmos in the Pod Space and Astronomy series.
It's a story of resilience and transformation that really highlights the power of life to adapt and evolve even in the face of catastrophic events.
So let's dive into this. You mentioned this massive asteroid impact.
Yeah.
What was the immediate aftermath of that event?
Well, imagine the force of millions of nuclear bombs going off at once. That's what happened when that 10-kilometer-wide asteroid crashed into the Yucatan Peninsula. The impact left a crater 180 kilometers wide and sent shockwaves rippling across the planet.
Okay, so it was a big explosion. But what about the long-term effects? What happened to the planet after the dust settled?
The immediate aftermath was truly apocalyptic. The impact threw trillions of tons of dust and debris into the atmosphere, blocking out the sun and plunging the Earth into a global winter that lasted for years. Temperatures plummeted and photosynthesis ground to a halt, leading to a mass extinction that wiped out 75% of life on Earth.
Wow, 75%. That's almost unimaginable. It's hard to believe anything survived at all.
It was a close call for life on Earth. Only the smallest and most adaptable creatures managed to make it through, mainly those weighing less than 25 kilograms. Think early mammals, birds, and some resilient reptiles.
So it's like the saying, the meek shall inherit the earth. Except in this case, it was the tiny and tenacious who inherited the post-asteroid world.
Exactly. And this extinction event, while devastating, actually created a unique opportunity for these survivors. With the dinosaurs out of the picture, they had a chance to diversify and evolve into new forms, eventually filling all those empty ecological niches.
So from the ashes of destruction rose a new era for life on Earth.
Precisely. The Paleocene epoch, which followed the impact, was a time of recovery and renewal. The skies gradually cleared, temperatures rose, and life began to reclaim the devastated landscapes. Early mammals thrived in this warm, humid world, and flowering plants spread rapidly across the globe.
But this period of recovery didn't last forever, right?
Right. Earth's climate is never static. Towards the end of the Paleocene, around 56 million years ago, there was a dramatic shift towards even warmer conditions. This period, known as the Paleocene-Eocene thermal maximum, or PTM, saw global temperatures spike by as much as 5 to 8 degrees Celsius.
What caused this sudden heat wave?
Scientists believe a massive release of carbon dioxide and methane into the atmosphere triggered this rapid warming. The exact source of these greenhouse gases is still debated, but one leading theory points to volcanic activity in the North Atlantic, which released huge amounts of methane trapped in ocean sediments.
So volcanic eruptions essentially turned up the planet's thermostat.
That's one way to put it. And the spike in greenhouse gases had a dramatic effect on the climate. The PTM lasted for about 200,000 years, and during that time, tropical climates extended all the way to the poles. Imagine palm trees growing in what is now Greenland and crocodiles swimming in the Arctic Ocean.
That's wild.
Yeah.
It's hard to picture a world so different from our own. But eventually this hothouse period came to an end, right?
Yes, thankfully. Over millions of years, Earth's climate gradually cooled down, but it wasn't a smooth transition. There were ups and downs along the way, driven by a complex interplay of factors.
Like what?
Well, one of the key players in this climate drama was plate tectonics. The movement of Earth's continents had a profound impact on ocean currents, wind patterns, and the distribution of heat around the globe.
So continents essentially act like giant climate regulators.
That's a good way to think about it. For example, the collision of India with Asia, which began around 50 million years ago, led to the formation of the Himalayan mountains. These towering peaks altered atmospheric circulation patterns, and some scientists believe they played a role in the long-term cooling trend that followed the PTM.
That's incredible mountains shaping the climate of the entire planet.
It's a testament to the interconnectedness of Earth's systems. But mountains weren't the only factor at play.
Okay, what else was going on?
Well, around the same time that the Himalayas were rising, another important development was taking place, the evolution of a new type of photosynthesis called C4 photosynthesis.
Hold on, I remember reading about C4 photosynthesis, but I didn't quite grasp its significance. Can you explain that for me and for our listeners?
Of course, C4 photosynthesis is a more efficient way for plants to convert sunlight into energy, especially in hot, dry environments. And this adaptation had a surprising consequence. It actually helped to cool the planet.
I'm intrigued. How did plants cool the planet?
Well, C4 plants are much better at absorbing carbon dioxide from the atmosphere than their older C3 counterparts. As these C4 plants spread across the globe, they effectively pulled carbon dioxide out of the air, reducing the greenhouse effect and contributing to the long-term cooling trend.
So plants were acting like giant air purifiers, scrubbing carbon dioxide from the atmosphere.
Exactly. And this shift towards C4 plants also had a profound impact on the evolution of herbivores.
How so?
Well, C4 plants are tougher and more fibrous than C3 plants, which made them more difficult to digest. This created a selective pressure that favored animals with specialized teeth and digestive systems capable of breaking down these tough plant materials.
So the rise of C4 plants essentially drove the evolution of grazing mammals.
You got it. Horses, cows, and many other grazing animals that we see today owe their existence in part to this ancient shift in plant life.
Wow, I never realized how interconnected the evolution of plants and animals is with the Earth's climate. It's like a giant complex dance with each partner influencing the others.
That's a great analogy. And this dance was about to get even more dramatic as the Earth headed towards another major climate shift.
You've definitely piqued my curiosity. What happened next?
Well, let's just say things were about to get a whole lot cooler, and this next chapter in Earth's story would set the stage for the rise of a truly remarkable species, humans.
Welcome back to Cosmos in a Pod. Before the break, we were talking about how the Earth was cooling down, and you hinted at some dramatic changes on the horizon. What exactly was happening?
Well, about 34 million years ago, Earth entered the Oligocene epoch, and this period saw a significant shift towards cooler and drier conditions.
What caused this shift? Was it another asteroid impact?
No, this time it wasn't an extraterrestrial event. It was a combination of factors, including those ever-shifting continents and a few other key players.
All right, let's break it down. What were these other players that were influencing the climate?
One major player was the ongoing growth of those massive mountain ranges we talked about earlier, like the Himalayas and the Alps. As these mountains continued to rise, they disrupted atmospheric circulation patterns and contributed to global cooling.
So those mountains were acting like giant air conditioners.
That's a good way to put it. They were also playing a role in another important change: the isolation of Antarctica.
Antarctica. How did mountains isolate a whole continent?
As the continents shifted, Antarctica drifted southward and became completely surrounded by ocean. This allowed a powerful current to develop around the continent, effectively isolating it from warmer waters and air currents.
So Antarctica was cut off from the planetary heat circulating around the globe.
Exactly. And without that warm water and air, Antarctica began to cool down dramatically. And as it cooled, vast ice sheets started to form.
Wait, so is this the beginning of the ice caps we see today?
You got it. The formation of these massive ice sheets on Antarctica had a ripple effect on the entire planet. Ice reflects sunlight back into space, which further reduces global temperatures.
So the more ice you have, the colder it gets, and the colder it gets, the more ice forms. It's like a self-reinforcing cycle.
That's exactly right. And this cycle played a crucial role in shaping the next chapter of Earth's story: the Pleistocene epoch, better known as the Ice Age.
Okay, the Ice Age. That's a pretty iconic period in Earth's history, filled with images of woolly mammoths and saber-toothed cats roaming frozen landscapes.
It was a time of dramatic swings between glacial and interglacial periods driven by something called Milankovitch cycles.
I've heard that term before, but I admit I'm a little fuzzy on the details.
Mhm.
Can you give us a quick refresher on what these cycles are all about?
Sure, Milankovitch cycles are basically long-term variations in Earth's orbit. And tilt's kind of like the subtle wobble in our planet's spin as it travels around the sun.
Okay, so Earth's not spinning perfectly straight.
Right. And these variations, while subtle, have a big impact on the amount of solar radiation that reaches different parts of the Earth at different times of the year. Sometimes these variations bring more sunlight to the northern hemisphere, sometimes less, and over tens of thousands of years, these changes can trigger the advance or retreat of glaciers.
So it's not just about how much sunlight Earth receives overall, but also how that sunlight is distributed across the planet.
That's the key point. And during the Pleistocene, these orbital variations, combined with other factors like the position of the continents and the continued growth of ice sheets, led to a series of glacial cycles that dramatically reshaped the planet.
I can imagine glaciers are incredibly powerful forces.
Absolutely. During the peak of these glacial periods, ice sheets covered vast swaths of North America, Europe, and Asia, reaching thicknesses of up to several kilometers. They carved out valleys, sculpted mountains, and left behind a legacy of glacial lakes and moraines that we can still see today.
It's mind-blowing to think about these enormous ice sheets reshaping the landscape. But what was it like for the life that had to adapt to these extreme conditions?
The Ice Age was a time of great challenges and opportunities for life on Earth. Many animals adapted to the cold by developing thick fur coats, like the iconic woolly mammoth, or by migrating to warmer regions. Others, like the saber-toothed cats and dire wolves, evolved specialized hunting techniques to survive in these harsh environments.
It sounds like a brutal but fascinating time to be alive. And wasn't this also the period when our own species, Homo sapiens, emerged?
That's right. The Pleistocene was a crucible of evolution for humans. Our ancestors had to be incredibly resourceful and adaptable to survive these glacial cycles. They developed sophisticated tools, learned to control fire, and honed their social skills to cooperate and thrive in these challenging environments.
So while glaciers were carving up the landscape, humans were carving out their own niche in the world.
Exactly. And by the late Pleistocene, humans had spread across continents, reaching Australia, Europe, and even the Americas. They were not just surviving, they were beginning to thrive and shape the world around them.
It's an incredible story of resilience and ingenuity. But the Ice Age eventually came to an end, right? What triggered the transition to the warmer world we know today?
Well, around 11,700 years ago, the last glacial period ended, and the Earth entered a new interglacial period, the Holocene, which continues to this day.
So we're currently living in an interglacial period. That's a bit unsettling considering all the talk about climate change.
It is a bit ironic, isn't it? But the Holocene, despite its relative warmth and stability, has also seen its share of climate fluctuations, and one of the most significant shifts in this epoch has been driven by, well, us.
Okay, I was wondering when we were going to get to that, the Anthropocene, the age of humans.
That's right. The Anthropocene is a proposed epoch that marks the point in Earth's history when human activities began to have a significant global impact on the planet's climate and ecosystems.
And it's a story that's still unfolding with consequences that are only beginning to be understood. Welcome back to Cosmos in a Pod. We've been on this whirlwind tour of Earth's history, from asteroid impacts to ice ages, and now we're facing this new era, the Anthropocene, where humans have become a force of nature.
Yeah, it's a sobering realization, isn't it? We've gone from adapting to Earth's changes to becoming the agents of change ourselves.
The sources paint a pretty stark picture of the impact we've had on the planet. Where do we even begin to unravel this?
Well, I think a good starting point is the Industrial Revolution, which began in the late 18th century. That's when we really started to ramp up our consumption of fossil fuels, coal oil, and natural gas to power our factories, our homes, and our transportation systems.
And burning all those fossil fuels releases massive amounts of carbon dioxide into the atmosphere.
Right, exactly.
Yeah.
It's like we've been pumping the Earth's atmosphere full of greenhouse gases, and that's causing the planet to warm up at an unprecedented rate.
The sources mention something called the hockey stick graph, which shows a dramatic spike in global temperatures in recent decades.
Yeah, that's a powerful visual representation of what's happening. For thousands of years, Earth's climate remained relatively stable, but in the last century or so, temperatures have shot up, and that's directly correlated with the increase in greenhouse gas emissions from human activities.
And it's not just the burning of fossil fuels that's contributing to the problem, right?
No, it's a whole suite of activities. Deforestation, agriculture, and industrial processes all release greenhouse gases and disrupt the delicate balance of Earth's climate system.
It's almost overwhelming to think about all the ways we're impacting the planet. But what are the most pressing consequences of this warming trend?
Well, one of the most obvious consequences is the melting of glaciers and ice sheets, which is leading to rising sea levels. This threatens coastal communities around the world and could displace millions of people in the coming decades.
The sources also mentioned extreme weather events becoming more frequent and intense.
That's right. As the planet warms, we're seeing more heat waves, droughts, floods, and powerful storms. These events can have devastating impacts on human lives, infrastructure, and ecosystems.
It's a bleak picture for sure. But are there any glimmers of hope? Can we reverse course and mitigate the impacts of the Anthropocene?
That's the million-dollar question. The good news is that we have the knowledge and the technology to transition to a more sustainable future. We can shift to renewable energy sources, develop more efficient technologies, and adopt practices that reduce our carbon footprint.
But it's going to take a concerted effort from individuals, governments, and industries around the world, right?
Absolutely. It's a global challenge that requires global cooperation. We need to make bold decisions, invest in innovation, and fundamentally rethink our relationship with the planet.
It's a tall order, but it's one we can't afford to ignore. The future of our species and all life on Earth depends on it. It's been quite a journey, hasn't it? From a world dominated by giant reptiles to the rise of mammals and ultimately the emergence of our own species. We've seen the power of life to adapt and evolve even in the face of incredible challenges. But now we're facing a challenge of our own making. And the choices we make today will determine the course of Earth's history for generations to come.
It's a humbling thought, isn't it? We have the power to shape the future, but we also have a responsibility to use that power wisely. We need to remember that we're part of this intricate web of life, and our actions have consequences. We can't just keep pushing the planet to its limits. We need to find a way to live in balance with nature.
That's a powerful message, and it's one that we hope our listeners will take to heart. It's been a fascinating exploration, and we're grateful to have had you as our guide.
It's been my pleasure, and I hope this deep dive has inspired you to learn more about our planet and to think about the role you can play in creating a more sustainable future.
So all our listeners out there, thanks for joining us on this incredible journey through time. We hope you've enjoyed it, and we encourage you to continue exploring the wonders of the cosmos. And don't forget to subscribe to Cosmos in a Pod and our YouTube channel for more deep dives into the universe and our place within it. Until next time, keep looking up.